Okay, so in this video, I want to go through concave lenses, or in other words, diverging lenses. Now, just to recap, in my last video, we said that convex lenses can form any sort of image. So it can be real or virtual, enlarged or diminished, upright or inverted. So any scenario is possible. So you've got that's any scenario for a convex lens. Okay, for a diverging lens, things are slightly different. They form a specific type of image. So let's again draw our principal axis. We're going to draw our diverging lens in the middle. Now the shape of these lenses is that they're actually thicker at the top and at the bottom and thinner in the center. So the opposite to a concave lens, the opposite to a convex lens. So it looks something like that. Now, again, if I draw my object, I have my observer. So we've got someone actually looking at an object. So this could be a person. So we're looking at an object through the lens. Again, we're going to first draw a parallel ray. And this time, it gets diverged, or it diverges at the lens. But the way to know which direction it diverges in is we trace back from the focal point and then we draw our ray like that. Okay, and then again we draw a central ray that goes through completely unrefracted. So again, we've got the same two rays. We've got our parallel ray and we've also got our central ray. And so this time, to draw our parallel ray, the direction it diverges at, or the angle, depends on the position of the focal point. So if you trace back, we should get a completely straight line. Now the image is then formed where the two rays meet, or appear to meet in this case, because as you can see, we've got a dashed line. The light rays don't actually meet. So that's going to be my image over here. Okay, so we can see that it forms a virtual image, and that's because light rays only appear to meet. They don't actually meet. Okay, so now let's go straight into an example then. And let's have the example where the object distance is larger than the focal length. So again, I'm going to draw my principal axis, my diverging lens. Now this time, the way we draw these diagrams is with sort of an upside down arrow. And as you can see, if you did connect it, it would trace out the shape. So now let's place my observer over here. And let's say they're looking at an object. So let's draw our focal points in. We're looking at an object over here. Okay, so again, ray number one, we draw my parallel ray. And this time, the parallel ray gets diverged, so it diverges at the lens, but we don't know how, so let's trace back to the focal point. Okay, so that's how my ray diverges. Next, we have a central ray that again goes through completely unrefracted. Where the two rays appear to meet, we get our object. We get our image formed where the two rays appear to meet. So we've got our image formed where two rays appear to meet. And as you can see, we've now got a virtual image because the rays don't actually meet, so it can't be projected onto a screen. We can see that it's actually upright because the arrow is pointing upwards, but it's diminished. Okay, so let's go on to example 2. And this is going to be when the object distance is less than the focal length. So again, let's draw my axis, draw my diverging lens. I'm going to place the observer over here this time. So all I'm doing is just switching which way round. Replacing the observer from the last video. And we've got our focal point. So we want to place our object within one focal length. Okay, so we've placed it over there. So try and pause the video and have a go. Remember to draw two rays. You need a parallel ray and you need that second ray that goes unrefracted. So if I draw my parallel ray, trace back to the focal point, diverges. Draw my second ray, doesn't get refracted. So I can see that my new image is formed there. So we can see that we've first of all got a virtual image, because again the light rays don't actually meet, they only appear to meet. And we also get that the image is diminished, but it's also upright. Okay, so to conclude, we have concave lenses. Now, instead of all scenarios like before, we can see that they only form virtual images. And the image is always diminished and upright. Now, in one of my later videos, I will go through some actual exam questions where we will apply some of these principles.